Students, today our topic is modern periodic table. In previous class, we have discussed about the Mendeleev periodic table, and today our topic is modern periodic table. Modern periodic table means the table which we are using in this day. Okay, in this day we are using modern periodic table. It is also known as the long periodic table, long form of the periodic table. So modern or long form of the periodic table is based on the modern periodic law. Students, according to Mendeleev, we have seen about the periodic law. What was the periodic law? Periodic law is that the properties of elements are repeated, are the periodic function of atomic mass. Means if we arrange the elements in order of increasing atomic mass, then their property will repeat after a period. But here modern periodic table, it is based on the atomic number, not on atomic masses. Okay. So according to modern periodic law, properties of elements are periodic function of their atomic numbers. Okay. Then the table is arrangement of elements in increasing order of atomic numbers. Mean in modern periodic table, we arrange the elements in increasing order of their atomic number. The modern periodic table is the present form of the periodic table, means the table which we are using in these days is known as the modern periodic table. It consists of 18 vertical columns and 7 horizontal rows. You can see here, this is the modern periodic table. It is also known long form of the periodic table. It based on the modern periodic law. Here, 7 horizontal rows. 7 horizontal rows. First one is this. Here only 2 elements are present, hydrogen and helium. This one is second. Here 8 elements are present, lithium to neon. Then third, fourth, fifth, sixth, 7. Means there are 7 horizontal rows. And these horizontal rows are known as the periods. So we can say there are 7 periods in modern periodic table. And we have already studied that there are also 7 periods in Mendeleev periodic table. There are 18 vertical columns. 18 vertical columns like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Means there are total 18 vertical columns. And these vertical columns are known as the groups. They are known as the groups. So we can say there are 18 groups in modern periodic table. But according to Mendeleev, there were how many groups were there? 8 groups. Okay. There are total 118 elements in modern periodic table. There are total 118 elements in modern periodic table. At the time of the Mendeleev, there were 63 elements only. 63 elements only at the time of the Mendeleev. And at Newland time, there were only 56 elements. But in modern periodic table, there are 118 elements. In first period, there are only 2 elements. In second, from lithium to neon, there are 8 elements. And in third period, there are also 8 elements. In fourth, there are from potassium to krypton, there are 18. And in fifth period also, there are 18 elements. But in sixth period, there are total 18 plus we will include this lanthanoid series. This one series we will also include in sixth period. Okay, this is also part of the sixth period, and these are known as the lanthanoids element, and this series is known as lanthanoid series. Okay, there are 14 elements in this series: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So in sixth period, total 18 plus 14, there are 32 elements in sixth period. And in seventh period, there are 18 plus this actinoid series. This is known as the actinoid series. It is also part of the seventh period. There are again 18 elements in this series. Okay, so again there are 18 plus 14, 32 elements. So after adding all, we will get 2 plus 8, 10, 10 plus 8, 18, 18 plus 8, 18, 36, plus 18, 54. So 54 plus 32 plus 32, 64. So there are total 118 elements in modern periodic table. Students, here period tells about the Here periods tells about the principal quantum number. Principal quantum numbers means principal quantum number is n. N. Here we can see, if I take this element, this one is phosphorus. So first of all we will write the configuration of element. After writing configuration only, with value of the n, we can tell about the period of that element. So if we don't know in which period it so what is the configuration for phosphorus? It is 1s2, 2s2, 2p6, then 3s. Okay, so you can see here n is 3, n is 3. Here value of n is 3 means this element lies in period number 3. Here value of n is 3 means the greatest number is known as the n. This is n minus 1. This is the penultimate cell. So penultimate cell is here 2. N minus 1, 2. Okay. So here you can see also. This is phosphorus. So it exists in 1, 2 and 3rd. So it lies in the 3rd period. So just after writing the electronic configuration, we can tell about the period of that element. It is clear to you or not? And students, groups tell us about the valence electron of an element. Groups tells about the valence electron means in which How many valence electron are there by which we can tell about the group of that element. Group in modern periodic table. So what do you mean by the group? We have already discussed the vertical columns are known as the groups. So groups are the vertical columns. These are the vertical columns in modern or long form of the periodic table. Means vertical columns are known as the groups, and there are 18 groups in periodic table. These groups are numbered from 1 to 18. We have already seen in our table that they are numbered from 1 to 18. Each group consists of elements having the same outer shell electronic configuration. Means with help of the valence electrons, with help of the electrons present in outermost shell, we can tell about the group of any element. It is clear to you or not? Yes. Now, periods in modern periodic table. We have already discussed that the horizontal rows present in modern periodic table are known as the periods. And there are total 7 periods in periodic table. And they are numbered from 1 to 7. From top to bottom. The first period consists only 2 elements. We have already seen this. It consists hydrogen and helium. While the second and third period consist 8 elements, fourth and fifth period consist of 18 elements each, and sixth period consists of 32 elements. 18 in sixth plus lanthanoid series. So there are total 32 elements. And in seventh period also there are 32 elements. Here 4 elements discovered. So they are the newly elements 117th, 18th, 113 and 15. So these addition has completed the period with 32 elements. Means there are 32 elements in period 7. Any doubt in this? Yes. Also, the long form of periodic table consists of a separate panel at the bottom. It consists of 14 elements of the sixth period called lanthanoids and 14 elements in seventh period called the actinoids. Each period represents the number of the shell or energy level present in an element. Here, these two separate series, these are known as the lanthanoid. First series is lanthanoid because here atomic number will be 58 to 71. It is known as lanthanoid series because it is part of the sixth period and it is started after lanthanum. Okay, so it is known as the lanthanoid series. And here actinoid series. Here atomic numbers are from 90 to 103. 19 to 103. Okay, so these are known as actinoid because this series is part of the seventh period and it starts just after actinum. Okay. And each period tells about the principal quantum number. And you know very well, principal quantum number tells about the energy level of the shell. Now, modern periodic law. What do you mean by the modern periodic law? It was given by Moseley. Mendeleev gave us periodic law. Means he told us that properties are periodic function of their atomic weight. But Moseley drew a graph between frequency and frequency of X-ray and atomic number. Then he found that the graph was a straight line. Means atomic number is going to increase gradually and it is continuous. It is a continuous graph. So, but there will be irregularity if he was plotted the graph with respect to the atomic masses in spite of atomic number. So he was not getting the straight line graph. So he said that there is irregularity between the atomic mass because there is not a fixed difference between the masses of the elements. Okay, but atomic numbers are regular. So properties are the periodic function of their atomic number, not periodic function of the atomic masses. It was told by the Muslim. So modern periodic law states that the physical and chemical properties of elements are periodic function of their atomic number. It is clear to you or not? Yes. Now, cause of periodicity in the modern periodic table. Properties are the periodic function. Why they are going to repeat it? Why periodicity take place? So what is the cause of periodicity? We will see. The cause of periodicity in properties is repetition of similar outer electronic configuration after certain interval. Because after an interval, their electronic configuration is repeated. Means number of valence electron present in the elements are going to repeat it. Okay, so their properties are also going to repeat it. You can see with help of the here, this is the hydrogen. Here you can see hydrogen. What is the atomic number of hydrogen? 1. So what will be the electronic configuration for this? 1s, 1. Then second element of this group will be lithium. Atomic number 3. So here electronic configuration is 1s2, 2s1. Then in sodium, sodium is 11. So configuration 1s2, 2s2, 2p6, 3s2. Sorry, 3s1. Then in potassium, what is the atomic number? 19. Configuration is 1s2, 2s2, 2p6. After that 3s2. Then 3p6. Then 4s1. Okay. So in same way, if you write configuration of rubidium, then last electron will be present in 5s1. Okay. So you can see from here that there is only one electron present. Okay, in all numbers. So electronic configuration is going to repeat it after an interval. So periodicity takes place. In any other period you can see. For example, if I say in 13, so here boron 5. So 1s2, 2s2, 2p1. Then aluminium, what is the atomic number? 13. So configuration for this 1s2, 2s2, 2p6, 3s2, 3p1. Okay, means again there are one electron present in p orbital. So configuration is going to repeat. Hence, their property is also going to repeat after a interval. It is clear to you or not? Yes. There are total four blocks in modern periodic table. First one is known as the S block. This group number 1 and 2 elements, they are known as the S block elements. And this block is known as S block. Group number 13 to 18 elements, they are known as the P block elements. This block is known as P block. And here, group number 3 to 12, it is known as D block. And elements are known as the D block elements. And here, this series, lanthanoid series and actinoid series, they are known as the F block elements. Why they are known? S block, P block, D block, how can we distinguish them? With help of their configuration, we can tell about the block of the element. Okay, these are known as the S block elements, group number 1 and 2, because here outermost electron is present in S orbital. In S orbital, their general configuration is ns1 to 2. Means in S orbital, either one electron may be present or two electrons may be present. Okay. If I talk about the group first, so group first elements have one electron in S orbital. So here, for example, if I want to write configuration for the potassium, here configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Because here outermost electron is present in S orbital. So this is known as element of the S block. Okay. So in S, this is N. Here N is the greatest number. Okay. So here N is 4. And S. In S orbital only one electron is present. But if I talk about calcium, so calcium is 20. What will be the configuration? 1s2, 2s, 2p, 3s, 3p, and 4s2. Okay. So there may be present either one electron in S orbital or there may be present two electrons. And because outermost electron is present in S orbital, so these elements are known as the S block elements. Okay. So these are known as the S block element. Group number first elements basically known as the alkali metals. Alkali metals. And elements of group number 2 are known as the alkaline earth metals. Then if I talk about P block elements, here what will be the general configuration for P block? For P block, general configuration is NS2, NP, 1 to 6. This will be the general configuration. For example, if I write configuration for boron, atomic number is 5. So configuration will be 1s2, 2s2, 2p1. Then For carbon, it will be 2p2. For nitrogen, 2p3. For oxygen, 2p4. For fluorine, 2p5. And for neon, 2p6. For neon, it will be 2p6. 1s2, 2s2, 2p6. Means here n is 2, here n is 2. So in S there are 2 electrons, ns2, and in P there may be from 1 to 6 electrons. In case of boron there are 1, in carbon 2, in nitrogen in p orbital there are 3 electrons, and in neon there are 6 electrons. Because here outermost electron is present in p orbital, so elements of this block are known as the p block elements. It is clear to you or not? Yes. Now, what is the configuration for S block? N minus 1 D 1 to 10 NS2. This will be the general configuration for D block elements. This will be the general configuration for D block element. For example, if I write for scandium. So scandium is, what is the atomic number of scandium? 21 it is. Write down configuration for this. 1s2, 2s 2, 2p6, 3s2, 3p6, 4s2, 3d1. This is the configuration for scandium. 2, 4, 10, 12, 18, 20 and 21. Here you can see n is the greatest number. So here this 4, it is n, and there are what happened? Okay, so you can see this is n. N is 4 here. And n minus 1 means 4 minus 1, 3. Okay, so here in outermost shell, in s orbital there are 2 electrons, and in penultimate shell, in n minus 1 means penultimate shell, and n minus 2 is known as anti-penultimate shell. There may be electrons in d orbital from 1 to 10. It is clear to you or not? So this is the general configuration for D block. Elements of D blocks are also known as the transition elements. They are known as the transition metals also. Transition metals. Then what is the configuration for D block elements? D block elements configuration we have already seen. So what will be the configuration for F block elements? For F block, n minus 2, F 1 to 14, n minus 1, D 0 or 1, NS2, NS2. This will be the general configuration for F block elements. You can write configuration for cerium. Ce. This is, it has atomic number 58. So now write electronic configuration for this. What will be the configuration? First of all, 1s, 2s, 2p, 3s, 3p, 3d, 4s, 1st of all, you will fill 2 electrons in S. So 1s2, then in 2s, 2s2, then in 2p, 2p, 6. After that in 3s, 3s2. After that in 3p, then 4s, then in 3d, then in 4p, then 5s, then in 4d, two to 4, 10, 12, 18, 20, then 30, 36, 38 and 10, 48. After 40 in 5p. So 54. Then in 6s. Then we will move to the 4f. 4, 10, 12, 18, 20, 30, 38, 48, 50, 48 plus 6, 54, 56. First in 2, then 6, 2, 6, 2, 10, 6, 2, then 10, 6, 2, yes, and 5d0. Then you can see n minus 2. Here what is the n? N is the greatest number. So here n is the 6. N is the 6. Okay. Here n is the 6. Okay. Then n minus 1. N minus 1 means D. Means in 5D there are 0 electrons. In D there may be either 0 or 1 only. Then in N is 6. So in NS there are 2 electrons. So this will be the general configuration for D F orbital. N minus 2 F1 to 14, N minus 1 0 to 1 and NS 2. So this will be the general configuration for F block elements. Okay. Here group number 13 elements basically known as boron family because it is started from boron. It is also known as carbon family, group number 14 elements. Group number 15 elements are known as nitrogen family and group number 16 elements are known as chalcogen. Group number 17 elements are known as halogen. And group number 18 elements are known as the inert gases. Inert gases or noble gases. Noble gases. because here all orbitals are filled. Their octet is already completed. So they are thus stable. So they do not react, okay, in simple conditions. So they are known as the inert gases or noble gases. Any doubt in this, beta? In any point, if you have any doubt, then you can ask. Okay, so this is all about the modern periodic table. There are total 118 elements. 92 elements are the naturally occurring elements, beta. And here 78% elements are metallic in nature. Here 78% elements are metallic in nature. Elements of group number first 2, they are metallic. Group number 3 to 12 mean D block elements, F block elements, they are all metallic in nature. And in P block, some elements are metallic, some are non-metallic, and the elements which are exist on this borderline, these are the metalloids. They are also known as semi-metals. Okay, so in next class we will discuss about metal, non-metal and metalloids. Okay, so this is enough for today. Thank you. Have a nice day.